Hi, so in this video, what we're going to do is we're going to look at differentiating the inverse sine function, which is arcsine of x with respect to x. So so arcsine of x is just exactly the same as what you would see on a standard scientific calculator, written as sine -1 of x. And again, some basic trigonometry. So sine inverse is not sine to the power of -1. So sine to the power of -1 is cosec of x, so 1 over sine of x. This is the inverse function. So to just make that clear, I'm going to write arcsine rather than this sine -1 notation. So yeah, we're going to differentiate arcsine of x. And to do this, we're going to do something similar to how we differentiated the natural logarithm of x, where we applied exponentials to both sides, and then we did some rearranging, a bit of implicit differentiation, i.e. the chain rule, and then we got the result. So we're going to do the same kind of technique here because we've proved the chain rule, sorry, and so we can use that technique in this question since we did that in previous videos. Okay, cool. So we've got arcsine of x, and what I'm going to do is just call that y. So we've got y equals arcsine of x. And then what I'm going to do to both sides is do the inverse of the arcsine function. And the inverse of the arcsine function is obviously just the sine function. So apply the sine function to both sides. And if we do that, we just get x on the left side and then sine y on the left-hand side. And then the key is now to differentiate both sides with respect to x. So similarly to what we did in the video where we differentiated the natural log, we can differentiate both sides with respect to x. So differentiate with respect to x. And if we do that, we're going to get dx by dx on the left side, and we're going to get d by dx of sine of y on the right side. Okay, so on the left side, that's simple enough. So we're differentiating x with respect to x. That's just the number 1. So we're going to get the number 1 there. And then now, so on the right side, this is implicit differentiation, which is just another way of saying the chain rule. So when we do the chain rule, we're differentiating a function of a function. And we're going to call this y. We're saying this y is a function of x, namely arcsine of x. And so to differentiate this, just using the chain rule that we did in previous videos, we want to differentiate this y, so this function inside the sine function, with respect to x. And then we want to differentiate the sine of y with respect to y. So with respect to that function inside there. So that's just using the chain rule by definition. And so what we're left with then is we're left with dy by dx. We can't do anything with that because that is literally just dy by dx. And then d by dy of sine of y. But when you differentiate sine, you get cos. This is just cos of y. And so this right-hand side must be just cos of y by dy by dx. Okay, great. So we're nearly there now. So we've got dy by dx in our equation, which is what we want because we want to calculate dy by dx. That's the whole idea. So we can divide both sides by cos y. And then that's going to leave us with dy by dx equals 1 over cos y. Okay, that's cool. So that's, I mean, that's essentially the answer, but we've got to get rid of this y variable on the right-hand side because we're working in the x variable. We want to differentiate arcsine of x with respect to x. So what we know then, well, we know by trig identities that sine squared plus cos squared is 1. So if we rearrange this and make cos subject to the formula, it should be clear that cos is just the square root of 1 minus sine squared of x. So subtract sine of x, sine squared from both sides, take the square root, and you'll get cos of x. So what we can actually do now, I'm going to go to a new page, is we can say that dy by dx, which is d by dx of arcsine of x, is 1 over cos of y, which is exactly the same as 1 over the square root of 1 minus sine squared of y. Okay, cool, so we've got that, but we still got we got to get rid of this sine of y all squared. But we know from up here that x equals sine of y. So that means that x squared equals sine of y all squared. And so we know that this is actually just 1 over the square root of 1 minus x squared. And so therefore dy by dx, and again we know that y is arcsine of x. So we conclude that d by dx of arcsine of x is 1 over the square root of 1 minus x squared. And that's the final answer.